Hey guys, we're now on page 18 in your packets, and we're going to learn mass-mass stoichiometry conversions. These are somewhat similar to the mole-to-mole conversions we did earlier, but they just require a couple more steps. What you're going to need to do this successfully is a calculator. You could use your phone. I can't tell you to put it away anymore. You need a periodic table. Again, if you don't have one, you could just Google periodic table in a different tab, and then you can go back and forth. I'm going to go through practice problems 1 and 2 and 3. And then I want you guys to try 2 and 4 on your own. So again, I'm going to try 1 and 3, and then your job is to do 2 and 4. The main difference between these and the problems we were doing earlier is these start in grams and end in grams, while the problems we were doing yesterday start in moles and end in moles. But you can see here that that is a step in this process. So this process is 4 steps, which sounds like a lot, but they're always the same. So it's quite predictable, and I know you guys can do it. I'm going to start by marking up my problem. I'm going to box what I know, and I'm going to put a question mark next to what I'm looking for. If you start with 56 grams of ethylene, how many grams of carbon dioxide will be produced? So I know I have 56 grams of ethylene. I'm looking for my grams of carbon dioxide. Always start by writing what you know at the beginning. "56 grams C2H4. So I need to go from grams of A, which is just what I know, we'll call it A, to moles of A. And then after I've done that, I use my molar ratio to get to moles of B, and then I can get to grams of B. So B is what I'm looking for. So to get from grams of A to moles of A, you put your grams at the bottom and 1 mole at the top. And I'm going to write 1 mole of C2H4 because I need to distinguish it from my products. So down here is always going to go the molar mass. And the molar mass is the mass of 1 mole. And as you remember, we get that from the periodic table. So I'm going to look on my periodic table and I'm going to find C and H. So C has a mass of 12. I'm just going to round to the nearest whole number. And H will have a mass of 1. So I'm going to write this down here. So I have C, I have H, and we're just going to calculate the molar mass like we did at the beginning of the unit. So here I have 12 times 2. Remember, the 12 was the mass from the periodic table, times 2 ethylenes, which is 2 for my chemical equation. And the mass of hydrogen is 1 times my 4 hydrogens. So in total, I have 24 plus 4, which is 28 grams. And I'm going to put that right down here. So that gets me from grams of my first thing to moles of my first thing. But I'm not done yet because I need to get from my grams of C2H4 into my grams of CO2. So in my next step here is to look at my chemical equation. And you can see here I'm starting with 56 grams of this. How many grams of that am I going to make? So in order to do this, we need to use our molar ratios. So now that I'm in moles, I can do that. So I put my moles of C2H4 at the bottom, and I'm going to get into moles of CO2. So this step here, this third step, is always the molar ratio. I always put what I'm trying to get to at the top and what I'm trying to cancel at the bottom. See here how it cancels. Now I fill in my ratio. So I'm going to look at my equation. I can see here that this one, C2H4, has no coefficient, so I assume a 1. I look over at CO2. CO2 has a coefficient of 2. So that is my molar ratio based off my chemical equation. My final step is to get from moles of CO2 into grams, because that's what the problem asked me to find. It asked me grams of CO2. So I'm going to put my mole of CO2 at the bottom. This number here is always going to be a 1. And this here is going to be my grams of CO2 based from the periodic table. So from go from moles to grams, I need to get the molar mass again. So over here is always going to go the molar mass of whatever it is you're looking for, which is CO2. So to find the molar mass, I'm going to put my work down here. So I'm going to put my mass of C, which was 12, times my 1C in CO2. And oxygen, again, you could see here, is 15.9999. So I'm going to round that to 16. And I have 2 oxygen, so times 2. So that's 12. 16 times 2 is 32. 12 plus 32 is 44. So I put the molar mass of CO2 up here. So again, I went from grams of my first thing to moles of my first thing. Then I used the periodic table for that. Then when I went from moles of my first thing to moles of my second thing, I used the molar ratio from my equation. And lastly, to get from moles of the second thing that I'm looking for into grams, I go ahead and I use my periodic table, the molar masses again. So to finish the problem, I need to multiply everything that's in my numerator by each other. So I'm going to show you guys on my calculator here. So I have 56 times 1 times 2 times 44. I'm going to write that number down. 4,928. Then I have to divide by everything that's in my denominator. So 28 times 1 times 1. I don't need a calculator for that because 28 times 1 times 1 is just 28. Then at the end, I divide my numerator by my denominator. So I have 4,928 divided by 28. And that gets me 176 grams. Don't forget to write your unit and write what your final answer was. So I was looking for grams of CO2, so I wrote CO2. And that's how I solve a stoichiometry problem. I'm going to also go through problem 3, and then your job is to do 2 and 4 on your own.